Welcome to part 8 of solving mazes with reinforcement learning. In the initial implementation of this code, I wrote a full training loop right here in main.py. But when I started looking at how that code structure played out for things like curriculum learning, I decided to go ahead and move it under the agent. So that is actually what we're going to do now. We are going to define a train and test method up under the agent itself, which I think is pretty clean from a design perspective. That means that the agent has the full ability to declare all of its own models, load its models, handle its own training loop, handle its own test loop, and then any other code is really just interacting with the agent. So with that in mind, let's go ahead and get started on our training loop here. So we're going to do this right above, and it doesn't really matter where. We'll do below update parameters. And I'm going to define train, self, env name, memory, episodes, and I'm going to default episodes to 1,000. We'll do batch size is defaulted to 64. Updates per step will be defaulted to 1. Summary writer name will be defaulted to blank. Max episodes steps will default to 100. So we'll go ahead and set our warm-up, which that's a good point to note. We no longer need warm-up over here. We need it in agent. So we'll say warm-up equals 20. That's just going to be static. We'll set up our TensorBoard. So TensorBoard, if you haven't used it before, is going to give us a nice graphical interface to see some of our data plotted. I tend to use TensorBoard these days right here in VS Code. You can also just launch a TensorBoard server on the command line and use it in any browser. It's a web accessible thing, but I'll be showing you my setup here in Visual Studio Code. So, summary writer name. So I passed it in here, but what I'm really going to do is have a base for the summary writer name that includes the date and puts it in runs, and then this will become something that is appended to that. So what this allows us to do, if you've trained anything like this from scratch before, as opposed to just walking through a video, it tends to take many iterations of tweaking parameters. This is not something that, hey, you sit down and code it all out in a couple of days and it all just works. Reality is that you're going to code it. It's going to take, weeks probably to get the code itself working. And then you're going to spend weeks more tuning things until your code does what you expect it to. So it can be very, very useful to see all of your training runs, or at least the last 20 or 30, and to be able to tell them apart. So that's why I included summary writer name and the ability to customize. But the base is going to be runs / datetime.datetime.now. And then we're going to do strf time and pay very close attention to the capitalization here. So % uppercase y, % lowercase m, dash % d, underscore, % uppercase h, dash % uppercase m, dash % uppercase s. And then we'll end it with an underscore, and we're going to add summary writer name to it. And then we'll say writer equals summary writer Oh, you know what? I bet I don't have summary writer imported, and that's why it doesn't want to autofill. From torch.utils.tensorboard import summary writer. All right, now we can go down and summary writer. There we go. And we're going to pass in summary writer name. And then we start actually coding our training loop here. So training loop. Total num steps. We're going to set total num steps to 0. We're going to set updates to 0. And then we're going to say for I episode in range episodes. And we'll do episode reward equals 0. So every episode we're going to, zero out the rewards and zero out the steps. Episode reward or episode steps equals 0. Done equals false, because we're just starting out. Of course, done is false. State, and we don't need info, equals env.reset. And then we start playing the game. So that's going to be while not done, and episode steps is less than max episode steps. So basically, unless we give it a done signal, and unless we hit whatever max episode steps is, we're going to keep learning, keep going. And my early experimentation showed that for the straight maze, the best you can really get out of it is going to come after about 100 steps, so you don't really need to train on that one very long. For the more complex mazes, we're going to train for quite a bit longer. It'll be 500 steps per episode and several thousand episodes. So we'll say if warmup is greater than I episode, then action is env.action space .sample, else action is self.select action. So basically for the warm-up period, just sample randomly from the environment because we're assuming the agent doesn't know anything yet, and then go ahead and start pulling from the real agent. So next up, we're going to say if memory.can sample. Let's go ahead and do the same thing over here. So we did pull in replay buffer already, so we're going to go ahead and tell this that it's a replay buffer type. And now we can say memory.can sample, and it understands and can autofill for us. So if memory can sample, batch size equals batch size. And if you remember from coding up the memory class, what we're basically saying is we're asking it if it has some arbitrary number of samples based on the batch size. And I think we coded it to batch size times 5. So basically, unless batch size times 5 values are in this memory buffer, we're not going to try to train on, do any training on it. So in here, we're going to say for I in range updates per step, critic 1 loss, critic 2 loss, policy loss, int loss, and alpha equals self.update parameters, memory, batch size, updates. And just to keep it all nice and clean, because this is a longer line, I'm going to pull all three of those things in a little bit and it's telling me updates are not defined. Let me see. We should have defined updates up here. We put update. It should have been updates. Okay, now updates is defined. And then we're going to do more TensorBoard. So writer.add scalar loss/critic 1. Critic 1 loss. Updates. So we're going to add a few of these lines, but let me explain what they do. This is going to name it. This will name the graph. This will be the actual value. So this is the actual thing we're going to plot. And then updates is the time step. So, it'll be plotting. If you're looking at it as your XY graph, critic 1 loss is your Y value, updates is your X value over time, and then loss/critic 1 is the actual name of the graph. The TensorBoard will also, if you do, a value followed by a /, it's going to group these things. So if I say loss /critic 1, it's going to group them all under a loss header, and I'll show you how that works when we get there. These will be very similar, so we're just going to copy several versions. So we'll do critic 2 loss. We'll do loss/policy is policy_loss. And loss/entropy loss, or just do loss/entropy, will be int loss. And we really won't need that here, but it was part of my implementation initially, so I'm going to go ahead and include it just to keep things a little bit cleaner. And then we can probably ignore everything else. We'll go ahead and say entropy parameters/alpha. So we're just going to graph our alpha parameter. Did not mean to go down that early. Alpha. There we go. All right. Now we're going to come out of our if block here. So basically, if memory can sample, go do training, graph the results, come back. Now we'll do next state, reward, done, and we don't need those two, equals env.step. Action. So go ahead and take the next step in the environment. And then we will increment our variables here. So episode steps plus equals 1. Total num steps plus equals 1. Episode reward plus equals reward. We want to keep track. We want to ignore the done signal if it happens because we hit the time horizon. So ignore the done signal if it comes from hitting the time horizon. And we're going to say mask equals 1 if episode steps equals max episode steps, else float not done. Okay. Here we'll go ahead and store transitions. So memory.store transition, state, action, reward, next state, mask, and state equals next state. So just kind of going through this again, we're looping through all of our episodes. If, while not done, we're taking some action. If we can do, if we can train because we have enough samples, we go ahead and run a training step for however many updates per step are defined. Then down here, we actually take that action. We increment our counters and get our reward. We store what just happened in memory, and then we go ahead and set state to next state so we're ready for the next round. Now, all that's left is to do some logging. So here we're going to say writer.add scalar reward / train episode reward I episode. And the fact that we so what this is going to do is it's going to give us our losses grouped together. It's going to give us our parameter logging, and then it's going to give us our episode count along with our episode rewards. So really, this is the value that you want to see go up over time. Ideally, you should see your losses go down, but really these are all just logging things out so that you can figure out what's happening with this one. All right. Finally, we're going to print, just give ourselves some text output. So episode here. And this is going to be I episode total steps is going to be total num steps. We'll do episode steps will be episode steps, and reward is going to be reward. Okay, and in fact, I think we're going to round, and we'll do episode reward, not just reward, and we'll round it to 2 digits. All right, and then finally, if I episode modulus 10 is 0, in other words, every 10 steps, we're going to go ahead and save a checkpoint of env name equals env name. All right, we have our train method. Let's go over here and try it out. So here we're going to say agent.train, and again we will need many parameters. We'll pass in env equals env, env name equals env name. I'm sure there's some way to derive that. I'll admit I got lazy towards the end there. Memory equals memory. Episodes, we're going to statically pass in 100 here for now. Let's go down to the next line since this is going to be long. Batch size equals batch size. Updates per step equals updates per step. Summary writer name equals, let's see, F, and I'm going to call this one straight maze. And then I'm going to feed in, because we're passing it the straight maze to learn on. And we're also going to feed in some of the key parameters. So I'm going to call this alpha, LR equals learning rate. We'll go ahead and say HS equals hidden size. And then we'll do A equals alpha. There's no magic to anything in that summary name. I'm picking things that I find useful to have logged. I tend to change this frequently throughout training. This is one of those things where I'll make small tweaks and then go update it to tell me to tell me which run I was on. So it's not uncommon for me to come in here and add something on the end that's like 3 layers and see how that training run goes. It's just a label. So, and then finally, max episode steps equals max episode steps. All right, let's go ahead and run it and see what breaks. Hey, all right, we got one missing paren. Let's go see. Aha. Okay, it says it's on line 103 of agent. So let's go look at 103 and see what I messed up. And I can see right here, we did f runs plus summary writer name. Nope, that all looks fine. Let's import date time, or import time, and see if that solves our problem. So import okay. Okay, still says unmatched paren, so that's fine. We'll take another look at this. So we're doing strf time. We've got our curly braces there. We've got our quotes. We've got our function declaration. All of that looks pretty all right. Let's see. Where, oh where? strf time equals paren. Let's see, summary writer name. All of that looks good. And I'm sure you're watching this and seeing exactly what I'm missing, but I am not. Despite the fact that I'm sure I should be. So let's see, %y minus %m, f from string of time. F string unmatched. Yep. I mean, is it not liking that? I think I know what's going on. I think it's not liking that I did double quotes here and double quotes on the outside. It's a very easy mistake to make. I'm going to change that to single quotes on the outside, and we'll see if we do any better. Hey, better. All right, let's go take a look now at buffer.py on line 25. So it's saying could not broadcast input array from shape 8 into shape 2. So it didn't like our choice of input arrays there. Let's go see. Just make sure that we got all of these set up correctly. So replay buffer size, input size equals observation size. N actions is action space dot shape. All of that looks good. Observation shape. So this feels like it's probably a problem with either the environment we're passing in or the, let's see. All right, I'm going to pause the video here for a moment and go find the error, and then I will return and tell you what it was. All right, I'm back, and I have found the issue and where I made my mistake here. So I came in here and printed out next state, and that is the 8 values that it's supposed to be, which makes sense, which means that this next state memory is the wrong shape. And in fact, next state memory should have been self-mem size by input size, not by n actions. So let's fix that, and let's come over here to main py and see what happens next. All right, so it didn't like save checkpoint. It said it got an unexpected argument env name, so that's fair. Let's go ahead and fix that. We'll just remove env name, let it figure its own stuff out there, and run it one more time. All right, now we have a mat1 and mat2 shapes cannot be multiplied error. So let's go over to our, in this case, it's probably going to be a problem in the model pi. So what this usually means, when you see a mat1 and mat2 shapes cannot be multiplied, it means that either your input is the wrong shape or you have a layer that is not the appropriate shape. And I'm guessing it's probably the layer is inappropriate. So let's go ahead and see if we can figure out which line this is on. So it's self-critic target, next state batch, so it's probably somewhere in the critic. Let's see, so it's saying model.py in line 43, and it doesn't like that linear 2 layer. So if we go look at our linear 2, that looks like it should be okay. That looks like it should be fine. So let's go see in forward, did we call linear 2? Okay, so there's linear 1, there's linear 2, linear 3. All of that looks exactly as it should. All of that looks fine. So this is specifically in our first, I see the problem. So you'll notice that my input variable there is xu, and because I did some copy paste, I copied and pasted xu into linear 2. So what this error is trying to tell us is that we're passing our input directly into the second layer, and it's the wrong shape. So this needs to actually be x1, and then this is going to have the same problem, so that needs to be x2 there on line 47. So xu is only the first input to the first layer in each scenario. So that makes a lot of sense. Let's go try it again. All right, let me just make sure I saved. All right, still doesn't like something. Now it's in line 48. Linear 6 doesn't like x1. So let's go take a look. And that also makes sense. X1 at this point has already been passed through linear 3. This should be x2. All right, we are making progress. We're no longer seeing errors in the model itself. Let's go take a look at agent.py and look at line 80 and see what we don't like, or what it doesn't like. So I see that we are calling policy sample with state batch and pi, and that should be, let me just check and make sure that is the right thing to have there. So I actually don't think we should have pi at all. I think we should probably just have sample state batch. And run again. All right, we are making progress here. So writer has no such attribute add scalar, and that is correct. It does not. It's add, I believe it's add scalar with an A. Okay. and we are now training. So, I mentioned earlier that we would have we'd have some TensorBoard logs, and those would be in VS Code. Let me show you how to access those. So I'm going to say Control-Shift-P launches the command palette for VS Code. I do have the TensorBoard extension. So I've got the TensorBoard VS Code extension, and I'm just going to launch TensorBoard. I always say no to this, and then I'm just going to click Use Current Working Directory, and that will start TensorBoard for me. Eventually. I also notice, while we're waiting for that to start, that it's giving this user warning, using a target size, blah, blah, blah. This will likely lead to incorrect results during broadcasting. That is probably going to cause us some issues. So we'll take a look at that in, if not this video, then the next. Failed to start TensorBoard session. What don't you like? After waiting 60 seconds for TensorBoard. Okay, so it did not like. Oh, hang on, let me make sure. Python launch TensorBoard. Yeah, that should always be okay to say no to. And this is the risk of setting up a new project to walk through something like this, is not everything works all the time. All right, so I will end the video here and figure out what's going on with the TensorBoard, and we will come back and pick back up with our logging and dig into this error here that's telling us our broadcasting shapes are wrong. You know, a hint, this should be getting better results than it is. Right now, this is getting a bunch of zeros. We should actually be getting some consistent successes towards the end, and we're not. So we will make that a topic of video 9.